Alright, continuing with 5.1, we're in the C video of this, and we're on example number 7. And again, applications, and this has to do with boats. And we have a motorboat. Takes 3 hours to make a downstream trip with a 3-mile-an-hour current. The return trip of the same current takes 5 hours. Okay, so it takes longer because we're going upstream, so we're fighting the current. Alright, so let's look at our chart. We've got our downstream and we have our upstream. Okay, so this is one where we've got a distance, a rate, and a time, so we're going to use D, R, and T. Okay, so do we know anything about distance? Absolutely not. We don't know how far we're going at all. So we're just going to put D's in for both distance because the distance up and the distance down are the same, so we can use D's for both of those because they're equal. Alright, all we're interested in is the speed of the boat in still wire. How fast is the boat going without any current? Alright, our rate. How fast are we going? Well, when we're going downstream, we're going 3 miles an hour faster than in still water. So we're going our speed sitting still plus 3 because the current's pushing us down 3. When we're going up, we're going our speed in still water, but because we're going against the current, we're losing 3 miles an hour because the current's pushing against us. And what do we know about time? 3 hours down, 5 hours up. So there is our chart. So what do we know about distance? Distance equals RT. So distance equals R times 3. And down here, distance will equal R. There. So there are our two equations. Okay, so let's go ahead and simplify these a little bit, and we'll bring them down here and do them in red. So we have 9 plus 3R equals D, and 5 times negative 3 is negative 15 plus 5R equals D. Alright, so let's look and see what we know here. We know that our distances are the same. So this, if these are the same, then these have to be the same, right? If this distance equals that and distance equals that, well, both of them are D's, so that means this number here and this number here have to be the same. So I can rewrite this then as 9 plus 3R equals 5R minus 15. I just switch these two around. And then I go ahead and find out what my R is. R is 12. So my rate in still water is R. So we didn't even use systems of equations. We just used some common sense, some logic, made our table, and then we're able to solve that. Okay, last equation. Example 8. Suppose that the price and the supply of the star station satellite radio are related by the equation. So they give us an equation. We really don't know what's going on here, but we do have an equation, so that helps. Okay, so there's an equation they just gave us. The price and the supply. Okay, knowing that price, one of these is going to be price and one of these is going to be supply. So price goes up depending on how much product there is, the supply of the product, or it goes down depending on the supply of the product. Alright, where Y is the price, so that's how much the radio is, and X, it says, is how many thousand units there are. Okay, so usually when you buy like a ton of stuff, the price goes down. So that hopefully is probably what we're gonna look at here. So X is the number of radios we have. Y is the minimum price the seller is willing to sell them for. Okay, so if you buy 100 of them, you're probably going to get a better deal than if you buy just one. So the second part says, suppose that the price and the demand of the radio. Okay, so in the other one, this was the price. And now we're talking about why, being how much is somebody willing to pay. So it's still price, but how much is somebody willing to pay for a radio? And it gives you an equation. And again, you don't have to understand everything that's going on here. You just know that you have two equations here. All right. So the equilibrium point of this product is where both people are happy. The person selling the radio and the person buying the radio, they're both happy. They're both okay with it. All right. So there's our two equations. You do your substitution or your elimination, and you solve this. And then finally, when you go and graph this, you're going to get a point where both people are happy, the equilibrium point. So we're not going to do this problem. I don't have any in the homework, but I did want you to at least be somewhat familiar with how this works and some of the vocabulary there. So that's it for 5.1.